This conference will now be recorded.
Good morning, good evening, and good afternoon, folks. Welcome to this SONiC community meeting. We have two HLD need to be reviewed in today's meeting. So both of them are contributed by Broadcom. So I just shared the link, the PR link in the chat window. You can, open the HLD for yourself. So let me ground the presenter to 11.
Yeah, please.
Yeah, go ahead. So 11, you should be the presenter now.
Let me try one second. Second.
So 11, there should be a screen windows. Sorry, the screen button. You need to click that button.
I'm trying to do that. There is some preference option that system is not able to share the screen. Give me a minute. I may have to restart the GoTo.
So Lavini, if you have trouble with that, I mean, if you have trouble, trying to stream, maybe we can have Julia go first. I mean, do you think you can get it now?
Yeah, I enable the permissions. Can you make me the presenter? I can try to share the screen again.
Sorry, you should be the presenter. What do you mean then?
My GoToMeeting was restarted, so I wanted to see if I'm still the presenter.
Yeah, I make you the presenter. I see two of you, so I make you the presenter.
Okay, thank you. Can you see the screen now?
Yes.
Is my screen visible?
Yeah, we can see the screen. Yeah. Yeah, go ahead.
Okay. Yeah, so this HLD is neighbor refresh HLD. So the main objective of this HLD is to come up with a design which overcomes the shortfall in ARP update script. So currently we have neighbor entries learned in the kernel, and the neighbor entries are processed by SWS's modules to program the neighbor in the hardware. But there is always a chance either the neighbor or the Mac could age out. And due to the age out, there could be a possible traffic drop in the hardware. In order to avoid traffic being dropped in the hardware, we want to refresh the neighbor before the neighbor is aged out in the kernel or before the Mac is aged out in the hardware. So that is the basic objective. So SONiC already has an ARP update helper script, which periodically runs every 5 minutes, and it will refresh the neighbors using utilities like ARP ping, ND6, or the ping 6 utilities. So the ARP update script normally traverses the IP neighbor table either by a per VLAN interface and then send packet one by one. So the disadvantage in this method is that when the number of ARP entries or the neighbor entries increases in terms of 10K or 20K, the ARP update script will not be able to complete one iteration within a 5-minute interval. And there are cases where the CPU becomes busy and eventually we will not be able to refresh the neighbors in time. So this PR is mainly to come up with an alternate approach. Instead of using ARP update script, one of the SW's modules can take up the responsibility to send ARP packets from an application. Instead of using a script to send periodic refresh, we use the existing SW's module. In this case, it is a neighbor manager module, which will do the ARP refresh functionality. So the main requirement is that we have to refresh the ARP ND before the kernel does ARP ND age out. And in case of VLAN interfaces, in addition to the neighbor age out, we should also make sure that the ARP and NDs are refreshed before the corresponding MAC ages out. Because if the MAC ages out, then there is always a possibility the hardware, the packet will be dropped. And an additional requirement is that whenever there is a MAC delete event, either by administrative clear command or by any protocol flush, then the ARP ND has to be relearned so that refreshed so that the MAC will be relearned and the traffic convergence will be faster. So if we don't do ARP refresh as soon as the MAC is deleted, if we wait for ARP update script, then the ARP update script normally waits until 5 minutes and then until it gets triggered. So there's a possibility of traffic blackholing for the 5-minute interval. So these are the things that we can avoid if we move to a process-based solution rather than the existing ARP update script. So I would request if we have any queries or any comments with this, please let us know.
I think there is a good comments like from the command line part. I see you mentioned that no new command line are added. Just a reminder the community, if there is you have a new feature which either with the new command line or has some command line change, please make sure to update the command line reference page. So this is just a reminder to the community.
Okay. Currently, we do not have any new CLIs, but in future we will be adding CLIs to configure ARP and ND age out. So the recommend is to, if there is a CLI, we have to update the HLD with the CLI information in this HLD, right?
Yes, correct. I think you are good. Just take these opportunities to remind the community.
Okay, sure. Okay. With respect to the scalability, what we are trying to achieve is that the minimum we have to support at least 4K L3 interfaces and close to 30K neighbor entries should be able to refresh without taking CPU resources and should be able to resolve before the corresponding neighbor entries are aged out in the kernel. We can break the functionality into 3 parts. One is the basic refresh functionality, wherein you learn the entry from kernel and you refresh those entries via the neighbor manager D module. The next is that in case of VLAN interface, we should refresh the neighbor entries before the FDB entry edges out. So in case of VLAN interfaces, in addition to the R per ND age out, we should also take into consideration the MAC age out, which could happen either in the kernel or in the hardware. Normally, the recommendation is to have the age out in both the kernel and the hardware as the same age out value, so that whenever MAC gets aged out in the hardware, the notification will be processed by syncd and ARC agent, and eventually the state DB will be removed. As soon as the state DB FDB entry is deleted, then we can use that as a trigger to refresh the neighbor entries which are using those MAC. And the third recommend is that in addition to the regular refresh that we are doing based on age out, if administrative command is executed to clear the MAC, in that case also the ARP and the refresh functionality should happen such that the traffic is converged as soon as the MAC is removed and MAC is learned.
Lavin, regarding the requirement too, right? I think you said it should be dropped in the ASIC. So I believe that is behavior of a Broadcom, right? So I think some platform does flood the packet. So like Innovium, right? Basically, it floods the packet. So just observation.
Okay. So, but okay. The flooding is also not recommended because this is a routed packet. So in such cases, what will happen is that the DA will be the switch DA, which is flooding the packet. So when it goes to the next device, then that device will also not consume the packet. It will again flood. So it will just increase the number of packets in the network. So the recommendation is to drop the packet in the hardware.
Okay. Yeah.
But then I think Lavin, maybe we can change this requirement number 2 to describe this more generically instead of just saying drop.
Okay, sure. I'll take that as a recommend.
Thank you.
Okay.
Are we creating a new process for ARP and D to handle this new enhancement?
No, we'll be using Neighbor Manager D module for this enhancement.
I see.
Yeah.
Is it possible to highlight the exact difference in the new enhancement compared to what was there in SONiC earlier?
Yes, currently the recommend 2 and 3 are not there. And we have recommend 1, which happens via the ARP update script. But there are limitations with that also. So we can highlight those, which I briefly talked about. One is that consumption of CPU resources. The other is the time taken to process in terms of scale. And then the ability to control the number of packets that can be transmitted. So I can highlight the differences between current and the new refresh.
Thanks. And in terms of how this might work with respect to sticky MAC in EVPN, is there no change with respect to the control plane learn MAC?
The control plane learn MAC will be configured as a static permanent entry in the kernel. So since the MAC is already learned, we will not have an issue with the neighbor without the MAC. If the MAC is removed and there is a neighbor, as soon as if the MAC is not found in any of the state FDB tables, then there will be the process will add this neighbor into a refresh queue, and it will periodically refresh, try to resolve the MAC.
From the source side?
From
of the MAC where it was locally learned?
Yeah.
Okay. Maybe it will be good to mention something about since it exists in SONiC, how this might affect or not affect.
Okay. With respect to EVP and MAC handling.
Yes.
Okay.
Lavin, one quick question on that. When you get the EVP and MAC sync, right? You said you program it as a static entry into the kernel, or the dynamic with the no MAC edge out?
Okay, there are two cases. One is with the L2VNI, which is programs the MAC as a NOR.
Right.
And the NOR entry is again, NUD NOR state is again a static entry in the kernel.
I'm wondering if you do any ping or something, if there is a MAC change, we're supposed to move to the newer port, not on the tunnel. Just wanted to make sure we have that.
Okay. Meaning as soon
Right,
as the
the
MAC is,
transition.
Yeah.
if the host moves from remote to local, right? So as soon as
Yeah.
the currently in one of the node, the host is remote. The way in which we identify the MAC, the station move is the MAC also should move. So as soon as only after the MAC move, that is when you learn the entry locally. Then BGP control plane will remove the MAC from all the other sessions, right?
Yeah.
So until we learn the MAC, I think the remote MAC will still be active and alive.
Okay.
Okay, so coming back to this design, this thing, currently we have segregated into multiple list of requirements, but in the current release, we want to support the basic use case of refreshing the ARP over a physical interface, so that we will have the infra and everything ready, and subsequent changes can be committed with less code changes, and we can enhance the features based on we can add additional features based on the infra. So this will not be a one-shot change wherein we bring in completely replace our update script with this design. It will be slowly adding support for R IPv6 on physical interfaces. Then we move on to other L3 interfaces. Then we bring in the recommend 2 and 3. So when we bring in VLAN interfaces, we will definitely also take into consideration the VPN use case, which is supported in SONiC.
So for the regular interfaces, router ports, Lavin, there is no MAC associated FDB entry. So which means, is it for the initial refresh, and then the kernel would take care of, I mean, when there is a transition from reachable to scale, why can't we handle it in the kernel itself? That's a smaller patch to handle that, right? Instead of moving those entries to the neighbor refresh script, right?
Yeah, I mean, two scenarios or two cases wherein, so I think there was already a point which was raised that if we send more number of TX than the COP RX limit,
Right.
then we will have a problem. So
Yeah.
which cannot be controlled if it is the kernel. The other is that we also want to add additional functionalities to the neighbor entries in the kernel. Say, for example, in case of failed entries, if an entry is learned as, if you're trying to resolve a neighbor and it is in failed state, currently there is no way to clear up the failed entries until user goes and cleans up the entry. Because the kernel will not remove the entry, because the kernel cache is such that even the entry is in failed state, it will not delete it.
I mean, that depends on the kernel settings that we have, soft limit versus the hard limit, right? I mean, if the limit goes beyond the configured hard limit or whatever,
threshold
it should
values.
flash.
Yeah. So
anyways, I'll thank you.
Yeah, meaning the what we wanted to add is that we can add more functionality into the neighbor cache, which are locally managed. than in the kernel.
Okay.
Okay, so we have a pretty detailed design document here. I think I can give you a high level of the design. So whenever neighbor is learned in the kernel, the neighbor syncd in SWS Docker will process the neighbor entries. So that is the existing design, which the neighbor syncd will add the entry into appdb, and then the Arc agent will listen to appdb neighbor table events and program the hardware. So now neighbor syncd, in addition to adding the entry in neighbor table in appdb, it will also add into our refresh table. Neighbor manager D module will be listening to this RF refresh table and then populates a local cache. So then the neighbor manager D module will operate based on the local cache to transmit the packets based on the timeout value. So this is the schema for refresh table. With respect to Arc agent, there is no change in Arc agent because all the other changes are handled within neighbor sync D and neighbor manager D. So the flow from neighbor table Arc agent to the hardware remains the same. There's no change in that. In this case, what we are only doing is that we are trying to form our refresh packet or the ICMP NS neighbor salutation packet from neighbor manager D, so that we can trigger a request to host in host, and based on the response that we receive, the ARP response or ICMP v6na, the MAC will be learned, and also the kernel timers are restarted based on the replay packets or the NA packets. So this is achieved by managing a couple of caches. One is the neighbor refresh cache based on the neighbor refresh table. The next thing is the interface cache. Interface cache is the neighbor manager module. Currently only listens to neighbor table, static neighbor events, config neighbor table. In addition, this will be updated such that it listens to all the L3 interface tables also. This is required so that we know the IP address associated with an L3 interface, and whenever we want to send an R packet out or the ICMP NS out, we want to fill the packets with the corresponding source IP. So for that purpose, we need the interface cache. So neighbor manager D will populate the interface cache as well. So there is something called FDB cache. This is nothing but a local copy of the state FDB table or the state MCLAG FDB table. This is to make sure that whenever an FDB entry is removed and we have a corresponding neighbor entry associated with that MAC, that neighbor has to be refreshed as soon as possible so that we can have a faster convergence.
So how is this FDB cache updated? Is it from the FDB
State
notification?
And this is whenever we learn a MAC, it gets notification to syncd. Syncd Arc agent FDB Arc module will process that notification from syncd. Then it creates a state FDB table. So the neighbor manager D will be listening to the state FDB events.
Okay.
So we will know that when a MAC is removed, OA will remove the MAC, FDB Arc will remove the MAC, and then it sends a delete event to syncd and hardware. The reverse is also possible. When the MAC gets aged out, we get a notification to FDB Arc. FDB Arc deletes the MAC from state FDB table. So neighbor manager D will be listening to the events from state FDB table.
Okay.
So Lavin, when the Mac ages out in the kernel, right? That's a separate event.
Currently, we are not handling the Mac age out from kernel.
Okay.
We recommend that we use same timeout in kernel and hardware.
Okay. Because there is a possibility that hardware may not age out because there is an active traffic, but whereas in the kernel it might age out, and if there are control traffic actively being sent later point in time, then it might flood from the kernel. So
okay, okay, so how we avoid or mitigate the situation is that we have an FDB age out, say 10 minutes. So the R refresh should happen within the 10-minute window.
okay.
So as soon as we send the packet out, we get a response. Based on the response, the kernel will also relearn the Mac. So kernel FDB timer will also be reset.
Okay. Okay. I mean, there is a window still, but you are making sure most of the time stay intact. Okay. Thank you.
Yeah. The next section talks about that. The way in which we compute the timeout is we take the minimum of Mac age or the R age. So for example, our neighbor age is 30 minutes and Mac age is 10 minutes. So we will take 10 minutes as the base timer. And then we random out the 10 minute between 30 to 70% interval. Then use that to send refresh packets. So because we consider Mac age also into the computation of the age out, the refresh age out. So we make sure that the kernel never ages out the entry. As long as we get the packet ARP response or the NA within that time frame, we will not age out. Okay. So as such, if you are asking us that whether we do any operation based on kernel events, no, currently we do not handle the kernel FDB edge out event. We only operate based on the state FDB events. So these are the basic modules that we have inside the neighbor manager D, all the caches, and then packet builder builds a packet and sends a packet, and the refresh timer, which will periodically checks for neighbor age out, and then if any of them has aged out based on the refresh timeout calculator, then it will send the packet.
So, Lavin, one question here is, are there any retries if the refresh app centers not responded or something, or is it like best effort?
It's best effort. In case of a regular refresh, it is best effort. But in case of Mac delete events, like FDB delete events, so we have a retry for 10 retries actually. It should be specified in one of the sections.
But can you explain again why do you need a retry for the Mac delete scenario?
Okay, so in case of Mac delete, what we want to achieve is the faster convergence, right? So there could be multiple things that could be happening. That could be multiple packets which are coming in to CPU, which will cause throttling of the CPU resources. So if you're trying to send a packet from application always the socket send will be success, but ultimately the packet might not have been transmitted based on the existing TXQ in the kernel. That is one scenario. The other scenario is that in case of MC lag, what will happen is that even though the packet is sent from one MC lag node, the response could come up on the other MC lag node. So it needs to be synchronized before the age out happens. So sometimes if this delay, there is a delay in synchronization, then there will be a delay in the traffic convergence.
So what are the retry parameters in that scenario?
The retry is only based on FDB delete. For in case of FDB delete, we'll add it to FDB refresh queue. And currently, the retry number of retries is fixed as 10, but it can be made as any configurable value. if needed.
Okay. So can you update those details in the HLD? I think it's not. Is it updated
Okay.
or?
I remember adding it somewhere. Okay, I can check.
Sure.
I can update that. Yeah, I think here we have the retries here, but
Okay.
I can elaborate more.
Sure.
Hi, Naveen. I had a couple of questions. So today, the ARP update script we run only if there is a VLAN configured on the device, right? We run only for VLAN interfaces. So in this use case, you are actually doing ARP update for RIFs. Why do we need to do that?
Yeah, ideally we do not need it. The main objective is that we want to populate a local cache in Neighbor Manager D. So one of the reasons why we don't do ARP update for neighbors learned on router interface is that as soon as you learn the neighbor will be in reachable state. Even if the neighbor ages out, it moves to stale, and it will remain in stale based on the configured GC values, the soft limit or the hard limit. So the entry will always be present. So CPU traffic will not be impacted. But if there is any scenario, say for example, if the entry is in failed state, and you keep the entry, you will also be keeping consuming the entry in the failed state. So that entry will also not be removed. So the objective is to build up a local cache for all L3 interfaces. Then we add some additional functionalities like removing the stale failed entries after say 3 refresh times. I tried for 3 refresh, still the entry is not changed from failed to reachable. So it's a good time to remove that entry from kernel also. So those functionalities can also be added.
Lavin, those could be tuned by, can be achieved by tuning the GC threshold values, right?
The GC threshold value is purely based on the count that whenever it deletes, it could delete any entry. It could be deleting a reachable entry also. So if you want to only delete failed entry, then we need more control.
Okay. Okay. And so my follow-up question is, what would, we are doing quite a lot of operation in ORC agent, right? Or in SWSS. What would be the CPU impact on this?
Okay, so the neighbor manager D normally traverses once in 30 seconds. So and it will only process the entries which are edged out. So we'll only handle the edged out entries and send the packet and come out. And there is also a threshold for TX, number of packets we can transmit out. So this way we control the CPU utilization of the neighbor manager D, also the number of packets that is transmitted out from the device in that one instance.
Right, but let's say if we SWSS restarts or we do some sort of reboot, then at boot up we are kind of refreshing for every neighbor, right? To get all together, then would that create like a CPU spike? Sorry.
Now, if SWSS alone is restarting, so in that case also we will learn the neighbors one by one in neighbor manager D. Whenever we are learning the entry, at that time we will not send the refresh. We'll always send refresh only after the refresh timeout calculation. So this will not be the computation is such that it is randomized between a certain value, so that we don't send too many packets at one instance. And even if you suddenly learn, say, 1,000 neighbors or 10K neighbors, it will not be transmitting all the sending the refresh for all these packets. It will send refresh only after timeout.
Okay. And last question. So you said we will be sending packets. Like, are we constructing the packet, or it's still using like ARP ping or utilities like that?
No, we'll be constructing the packets. So we'll be constructing our packets, ICMP V6 NS packets for using raw sockets.
So any reason why the utility may not work? Like, because today ARP update script uses ARP ping and IP ping 6, I think, right, for v6.
Yeah, so when we use utility, then if you're doing EXXE from neighbor manager D, then there is always an additional overhead, right? So we have to wait for the utility. Even though if we give timeout as 0 or timeout as 0.2, we will not be able to send more than what the utility currently allows us to send. If we could frame the packet and send it by ourselves, then we could send more number of packets in an instance.
Right, but wouldn't there be overhead?
Sorry, team, for the interruption, but I want to check the time. So we still have another HLD. I would suggest you guys to leave your comments online, and Levin can address offline.
So I think Enzo, Levin, one quick thing. I didn't join the first part, but we want to capture what is the motivation of this HLD. Okay, like what is the problem that we are trying to solve, and why the current ARP update script and the NDPD for IPv6 it's not solving this.
Yeah, we briefly captured a few of those. I can explicitly list out all the things that are not handled by ARP update script.
Okay. Yeah, I think we'll review it offline and get back.
Okay. Yeah, other than this, there's no change in SIMDR SI, and sequence is a simple sequence. In addition to neighbor table, we just had neighbor refresh table. There are a few use cases. Please add earlier queries as comments. I think we can go in deep as needed.
Okay, thank you. I think the big question is not about the technical details. It's actually about why we need this one, which I think we need Levin and Adam to clarify offline.
Yeah, I'll do that.
Okay, so I cannot see Jiahua. So Levin, can you just stop your share and I can find Jiahua?
Yeah, sure.
I'm online.
I think I can find it.
Should I
Okay,
share screen?
I make you the presenter, so please go ahead.
Okay. Here. Oh, you can see my screen, right?
Yes.
Oh, good. So, we are present here some SONiC external file support implementation details and enhancements. So first, everybody knows what file is, and so when we say external file, which means the file doesn't use the the SI or the switch SDK, right? So for the external file, there's using the what they call the gearbox framework, and the file use the what's called a PI. PI basically is the SI interface for the file, right? So most file use the MDIO interface, and for the MDIO interface, I mean access, there's two types: cross 45 and cross 22. And we from this diagram, you can see there's, I mean, for the gearbox framework, there will be two syncd, right? One's the regular syncd, which programs the switch, the MPU, and the another one, the GB syncd, programs the file. So unlike the NPU, which has the PCIe interface, and you have the memory mapped access to the register and the tables in the MPU, and MDIO, through the MDIO bus, and most CPU, then they have the MDIO bus on the CPU directly, and usually, you either need to add a FPGA CPLD to implement the MDIO, or most NPU comes with the MDIO bus, which means if you want to access the file, you have to go through the NPU. So depends on your platform, you would have two kind of approach when through some kind of IPC, in-process communication mechanism. Let the GB-SYNC talk to the SYNC, or you have the SysFS, basically it's a Linux kernel interface, right? You have Linux kernel driver, it has SysFS interface. So yeah, for this presentation, we're more focused on the one, using the NPU, and there's hints that there's IPC mechanism. So also in today's side, we already have the MDI, the MDL access defined in the side, but which then to distinguish class 45 and class 22. Although we have some other ways to distinguish that. Hopefully, on the one platform you only have one type of file, which either use 45 or 22. Then in the side configuration file, you can see all the file. When we see the MDL access come to the side, we know it's always 22 or 45, but that may not be true in general. So we request, we have the PR in the side, which we added the class 22 MDL access in the side, which I think is approved but not merged. Yeah, another problem we want to solve is today there's in the community SONiC, we already can see some gearbox implementation, and we can see there's at least two implementation. One is for the Credo 5, one is for Broadcom Broncos 5. So the way it does is it implemented the GB-SYNC dock. So basically there's two GB-SYNC dock. For the Credo, there's GB-SYNC dock, and for the Broncos, there's Broncos GB-SYNC dock. The reason is we build the GB-SYNC dock, at the build time, of course, right? Then we have to pack the Pi library at the build time. So hence there's a different GB-SYNC dock. So now even with the same libpi, and if you have a different MDIO access, like we showed, in this diagram, then you could have you might have to implement yet another GB-SYNC dock. So our design goal is like we want to have the GB-SYNC dock, just a single GB-SYNC dock, and you build it, and you just put all the access library, MDL access library, and all the libpi into the GB-SYNC dock, and use the GB-SYNC gearbox configure JSON file, to specify which one to use on this particular platform. So the SONiC image will decide which library to load at runtime. Of course, that's the commonly we use the the Unix DR open and the DR sim, this kind of mechanism, right? So yeah, so that's basically that's what we want to achieve. Yeah, so we have the the high level design things pretty much I already talked about. So we added one MDIO IPC server class and thread in the SYNC-D. And then we have MDL IPC client library, we added. Currently in the PR we submit, which has not been approved yet, we put it into the SONiC build image repo. I'm thinking probably I want to move to SONiC Redis repo. The reason is doing that, it will help us to do the unit test and all the tests much easier because the unit test is repo based. Yeah, so but we still want to build it as at least as a dynamic link library, and probably even better, that's dynamic link library will be packaged into its own Debian package by itself. Yeah. So as I said, we already submit the side API change, and hopefully that will go into the 1.11. So in the code for the the MDL access server, we already assume that we're going to the 1.11. There's a compilation flag in the code which is already merged. Yeah, so this is the for related code, the code PR, and we will have more to come. So in order to using the method of a dynamic link library to solve the issue of decide which MDL access library to use and which Pi library to use. So we propose we will change the vendor side class. So basically in the syncd main, we will have, at the runtime. So basically we will, just like in this picture, in the syncd is always running in the context 0, and any context larger than 0, yes, sync context 1 or 2, that's always we think it's for the GB syncd. Right? So we just overload the constructor of the vendor side, and the current vendor side has no argument. So we just passing the file ID and the context number, and we just in this code snap we can do that. Of course, we will have some new class variable to remember all the those the handler and the function point will be used later, just like when you're in the vendor side, those call the API, and we will use those. Right? And basically the MDL access function point is passing to the Pi at switch creation time. So in the vendor side create, we would have those things to decide which function to passing at the runtime. Yeah, those are the two functions I talked about. We newly added to the side API. And this is the one I talked about before. 1.11 side, we have to. I mean, this is for the Broadcom. We have the BCM config.bcm, right? We add one more property here. So basically, it's, for this platform, this is Arista PyXE platform. We say that's using the Broadcom Broncos 5, which is cross-22 only. And this is the one we added to the gearbox config.json, and we have two new keys added to the JSON file. And when we will know which access library we will use, and the other one we will see which it's class 22 only, or it's just the regular class 45. And there's already a lib name, which is for the Pi library name. It's already there. Yeah, we will use it. And yeah, so there's actually more issue like which are not addressed by our design. For example, usually the Pi library deals phi at the unit of a single phi, and most device would have multiple phi, and to learn, for example, you have 48 port RG45, which is a copper phi, right? And you want to have a 48 GB syncd, context. I mean, it's not very scalable, and there's some other issue, and we are not discussing this HLD. Yeah, this HLD is structured just for three purposes. One is to solve the MDL through the NPU. The second is to distinguish class 22 and class 45. And the third thing is we want to consolidate the the GBSync doc into a single GBSync doc and decide everything at runtime. Yeah. So there's some test case will be added. So basically, in the site interface and its derived class vendor side, we have added 4 new virtual functions. Basically, it's a virtual function in the site interface and the override, and are overridden in the vendor side class. And for the G test, unit test, since there's the dummy interface and the markable interface. Basically, you have to run this code. I mean, the real code only runs on the real hardware, and the G-test doesn't run real hardware. So, we have override it. So that's this way we can run the unit test. And if you happen to have a real hardware, and since we implement the those MDR access through the Unix socket, and you can use a socket to simulate the the IPC client. So basically, if you want to read the the register inside the file, you can do this. I mean, basically, there's 4 commands: read, write, and class 45 and class 22. And this is a socket. Basically, it's an interactive shells, and you can enter the shells, just regular Ctrl D. Yeah. So, yeah. Any question?
So one question I have. So this actually configures the external file via the MDO, right? So we do have
Yes.
one platform which is a mini pack, which is actually the Open Compute by the Meta, which actually does configuring the gearbox via the FPGA. So does this
FPGA.
support that? Yeah.
Yeah. So basically, what you need to do is in this one, right? The access library can be packaged into the GBSync doc, right? And in your gearbox config file, you just need to replace this line with your, your access library. You make the dynamic linkable. I mean, basically is a .so file, right? Then you just replace this. Sorry, I forgot to mention one thing. So we made the assumption that there will be the function name, and basically how the function, the argument is pretty much determined by the pi, and everybody seems to all agree on, what's the function prototype. So in this function, we made the assumption, you would have the the function if you are try to do the MDIO cross 22, then you have it's called MDIO CL22 read and MDIO CL22 write. And if you want to do the the cross 45 is MDIO read and MDIO write. So actually this is in this one, yeah. This let me see. Okay, open it. Yeah. Okay. How do I see the? No. Code.
So Jia, it's okay. I think we can update it offline.
Yeah.
To
so
address
actually,
this.
If you go there, you follow this link, you can find our code. And so the function name, yeah, probably I should express spell out, the assumption. And I think probably if we take this framework, then everybody has to agree on the function name to be called. Basically, there's only 4 functions: the cross 45 read write, and the cross 22 read write. Yeah. So as long as we follow the function name, we are all good.
Yeah, sure. Thank you.
I guess if we don't have any more questions, we can wrap up. Yansao, going back to you.
Okay, cool. Yeah, I think we just on time. Thank you, folks, for today's meeting. If you have any other comments, just leave on the online, so we can use the PR to continue the discussion. Okay, thank you.
Thanks, guys.